Thanks for coming to lecture. I've been grading the homework ones. Overall, I think everyone did really well. So glad to see that. I have like a 10 or few left to grade. And hopefully I'll get them all graded and in by today. If you guys saw, project 2 got posted. And so, standard questions from professor. And then there's also a new FEA question. And it's about a stepped plate in uniaxial tension, right? So the part will look something like this. And you guys will CAD that up and then load it up in ANSYS. And the reason I want to do a project like this is last lecture or like last homework, and we had like a few results where when you were analyzing, your plates, you might see, very high stress concentrations near the corners. That was intentional and that was expected. Those are singularities, right? You in ANSYS have defined a corner with an infinitesimally small point. And so if you have, from the first project, what is stress is force over area, internal reaction forces. If you have an infinitesimally small area, your stress is going to go to infinity or appear like it goes to infinity. So what you guys may have seen is that as you refine your mesh, the stress would just keep going up, right? And that was sort of the intention of that project. And this homework, that is also a bit of the intention, but hopefully this homework, I'll show you like how we can, get rid of that effect and make sure that we don't have stress concentrations which go to infinity. So for this homework, I have like a similar-ish example here. So this, I just made like a plate in NX, pretty simple. And what we're going to be studying here, and this is probably how you guys will do your project too, is you want to effectively apply edge blends to like a certain face. So in this case, it's a square in the center here, and we're going to be applying different edge blends. So you can change this up. So I think in the homework, I said like 1/4 inch and then 1/2 inch. And then an inch, right? And then you'll see how that affects your stress concentration. And so for this like sort of class example, what I'm going to be doing is I'm going to show you like how you can refine your mesh and how you can, hopefully detect if you guys have a stress concentration. So I'm going to be loading up this plate in ANSYS. I think this should be easy to CAD if any of you are following along here. It's just a 12 by 12 plate, 2.5 inch square in the center. But yeah. I'm going to load it up in ANSYS. So I've CAD'd it up already. So I'll just open the ANSYS file. Yeah. So standard thing as we've done before is you load in your step file here. And then after you've loaded in your step file, you can then drag and drop a static structural module. Then things you can go to engineering data. I haven't defined a material yet, so I'll do that now. So we'll do 61. Actually, I don't think I've shown this yet, so I might actually, yeah. I'll show it now. Delete this. ANSYS actually does have engineering data, which you can use. I usually like defining it myself because some of these data sources, you might not know exactly how you're modeling the part. You can see it has a bunch of different materials here. You can have composite materials, general materials. Right, so let's say I want to use like this is structural steel, stainless steel. So yeah, so I'm going to use ANSYS aluminium alloy here, just for this example. But for your project, I think I said what material to use. But yeah, just going to open this middle. Okay. So you can see that this is the plate. I'm actually going to delete what I've been doing. So you can start from fresh here. Okay, so standard like workflow, similar as always. You go from geometry import, everything's imported all right. And then you go to geometry. And we're going to change the assignment. So you can see, because you've defined it, now you can see the aluminium alloy. You can click here and make this aluminium. It's a material. And another good way to check is if I click structural steel and then click geometry, you'll see nothing's highlighted. But if I click aluminium alloy, you can see it's highlighted. You have to click this geometry. Okay, so I'm just going to generate like a default mesh here. And today also I'll be covering like more about mesh refinement and stuff. Now we can get better meshes. So you can see this is just, I'll actually show where I got this from. So initially when you generate a mesh, it'll look something like this. So yeah, the mesh will look something like this. This is just default mesh. It's created from your first project, you'll know that meshes with very like non-uniform shapes generally produce worse results. And a way to look at this is if you change the display style, get to element quality, sometimes you have to read. So you can see this like good graphical representation of mesh quality. So what we want to do is, in these regions, first let's just load it like this and see what we get. And then we can, change the mesh and then see how that updates stress concentration. So what I'm going to do is I'm going to load this in uniaxial tension. So I'll do 10,000 pounds. And then I'm going to put a fixed support here on the edge, right? And a way to show boundary conditions at once is if you click and then shift click, you can then see both these boundary conditions. at the same time. And this is like always a good screenshot to have in your projects because it's a good way to just show what you're applying in the model. And then it's a better understanding for learning what results you get. So now I'm just going to run this. So solve. You can see hopefully as you're running more ANSYS sims, this becomes sort of natural and you can, make a very simple sim very quickly. I think the hard thing in ANSYS is troubleshooting, and that's like a skill which is very hard to pick up on. But so all I did here was right click, insert, and then I'm doing a stress. You want to see stress here. I'm going to retrieve this result. Okay. You can see this is the initial like stress state of the part. So as similar to what you guys did in the project with the circle, you can see there's high stresses here. Another pro tip is if you want to probe results, like let's say you want to look at a result in a certain place, you go to result here and then you click this probe tool. And this probe tool lets you look at the node results for any node, right? So if I want to look at results here, or I want to look at results here or at max stress. And you click max, it shows max, shows where min is, stuff like that. A lot of cool things you can do in results. Yeah.
When you do that with the nodes, how can you make them go away?
Yes. So if you click graphical annotations, right, you can click these results here and you can right click and delete certain. So you can delete certain ones or you can delete all of them. So I'm going to delete all here and you can see the nodes are gone. But let's say I just put one here. And also this is really useful, this graphic annotation place, because let's say you want to like get these results into Excel. Sometimes you might do that where you're manipulating your results in ANSYS might be a bit hard. But let's say you want to get like a margin of safety per node location. What you could do is you could put all these like probes here, and then you could like copy this into Excel and then manipulate your data. It's pretty common. So good question. So how do you think we should go about, investigating the stress here? What do you think? Are there any thoughts of what we can do to manipulate the stress here to potentially look at these stress concentrations more, right? Because the mesh here right now is not too ideal. So any thoughts?
Yeah. You could make an extra fine mesh around that fold.
Yeah, that's exactly it. Good shout. So the way we'll be doing that, and I don't think I've covered this yet, so I think this will hopefully be helpful. It's helpful in general. So if you right click insert sizing, we've covered sizing. This is how to like change your meshes, right? So I click here, let's say I'm gonna make this 0.2, right? What this does is this is globally changing your mesh, not just locally. So everything now is 1/4 inch mesh, which honestly for this part would be fine because it's not like a really high detailed part. But let's say you're modeling a whole rocket, right? You can't have a really fine mesh everywhere because that'll take years to run. You need to sort of pick your battles maybe, or pick areas where you are most interested to refine your mesh. So we're gonna get rid of global body sizing here. So we're gonna try just refine the mesh in the middle. Does anyone know how you can do that, or what it's called in ANSYS? It's okay if you don't. I don't think I've covered it. But it's called a sphere of influence. And so what you have to do here is in the scoping method, you still keep geometry, but what you're going to change here is type. So when you right click insert sizing, you're going to change this to sphere of influence. There's also a bunch of different options like number of divisions. Let's say you want to manually set so it has like 10 elements in like a certain area. You would select number of divisions, but we're going to select sphere of influence here. Okay, so sphere of influence, it's asking for the sphere center, it's asking for a radius and an element size. So to define a center, you need to define a new coordinate system in ANSYS. And so I'll show you how to do that now. Okay, so right click, you would click insert here, and then coordinate system. So you're defining a new coordinate system. And here you can see it's defined by geometry selection. So I'm going to just define it by these 4 coordinates. And also, if you want to select multiple things in an ANSYS sim, you just hold shift. There you go. So I selected 4 of these. And so I'm going to define my new coordinate system by those 4 coordinates. And so now I have this new coordinate system. And so now if I go back to my sizing, I can then now say the sphere center, I'm going to define it using this new coordinate system. I could click global, but then if you click global, right, I'm going to be going to where the global is. And I don't really want my sphere to be here. I want it to be in this new coordinate system. So sphere center, we're going to do a coordinate system. I'm actually going to rename it. Okay, so now we want to give a sphere radius. And so the good thing is, I'm going to select geometry first as well. We're going to select the whole plate, but don't worry, you're not selecting the whole plate to be meshed. It's just, if you have multiple components, ANSYS needs to know which component you're selecting. We're going to select that. And I don't know why I've got such a weird view. I think it's because in my display. You can see there is a sphere is defined here. Sure. But that sphere is too small, so you're not actually updating the mesh yet. You can change the sphere radius. So we'll make it something like maybe 2.25. As you can see, you're only changing your mesh now in this region, right? And now you can select element size. So we know the global size is around like 0.8. So we're gonna make this 0.25. I'm gonna right click generate mesh. And you can see what's happened is now locally the mesh has gotten refined, but globally the mesh is still pretty coarse. And so previously, the way you might have refined meshes is if you right click insert, there's actually a refine tool, refinement here. And that specifically is on a face. So it does the same thing as this, but it's less granular control. Whereas with this, you can, choose the exact element size that you want. Another way to like update, whenever you're doing something, let's say, I don't want to use body sizing anymore, but I want to keep it for later, I can right click suppress it. And so now it's not active anymore. So now I can add a refinement actually. And so this was the old way that we might have been doing it. So right click refinement. You can see this only goes to like 1, 2, 3. You can't really choose like, what does 1, 2, 3 mean? I'll right click, it'll do a similar job. I think it changes it to text though. Yeah, it changes everything to text. You can see like how this is good, but let's say you don't want to mesh in text, and generally like when you have like a square plate like this, you don't really want to be meshing in text necessarily. I mean, you could, but so that's why this is better than refinement and why we might use this over. So right click, I'm going to generate this mesh again. Okay, and so now we have this refined mesh here. So what we're going to do is we're going to run 2 cases. So I'm going to do the suppress thing that I talked about later. I'm going to run this with just this case, and we're going to run a case with the refined mesh. I'm just running it with the normal case. Okay, and so now you have 1733 stress, and now I'm gonna unsuppress this. Let's change this element size to maybe like 0.1. Generate mesh. You can see this new mesh, and we're gonna solve it. So you can see stress went up by 1,000 psi. Now that's crazy because we literally have not changed our boundary conditions. The same load is being applied, the same constraints are in the model. All we've done is change our mesh size, but you are 33% off, or 33% higher stress. And so, that is basically like what I hope you guys will get out of this assignment is, when you're refining meshes and stuff like this, you might see a singularity. And so, the common thing to do is just, okay, this is my max stress, I'm just going to use this max stress. But hopefully you can see now that just because you have, some stress given here, it's really dependent on how you define mesh, right? Like I had a normal granular mesh, and that gave me 1,900 psi. But now I refined it just a bit, and I have 2,900 psi. Which one is the real one? Is the question, right? And so, like, if an actual answer to that is, well, this part is actually not manufacturable because everything has like a tiny fillet, right? There must be at least some edge blend in that radius, right? But the question is, like, let's say you do the min edge blend. How do you actually model that in ANSYS? And yeah, that's the main question. Like. And thing I hope you guys will get from this. But
And can I add something more to that?
yeah.
So the more you increase the mesh density, the more you're gonna find that that mesh density will be increasing that stress artificially. So the only way to really assess this is to put a plasticity model. Even if you put a plasticity model, you're gonna start seeing more and more plastic deformation. At that point, you have to put a crack that represents like an initial crack at that re-entrant corner, and then assess it from the fracture mechanics perspective. So when I was covering the comet failures that you saw early on with the square windows, the reason I had to move away from that is because they kept failing at the window because they were like this, square. And so to accommodate and fix this issue, they have to go to elliptical windows, which is what you see today in airplanes.
Yeah.
So a good design practice is to stay away from this kind of approach, right? One fillets, they're very helpful.
Yeah, it's to move to something like this with less of a fillet, right? You still have most of the functionality of the hull, but you remove the fillet and you're going to have way lower stress. Yeah. And so the step plate question is basically the same thing, right? You make fillets on these 4 corners and you should see the same effect that we're talking about here. It's a pretty simple model. We can get on to more like complicated or like more like fun models later. I know we're just doing plate stuff right now, but I think it's important to cover the basics, like stuff like singularities. Like I was doing ANSYS for like 6-7 months, and I still was like, singularity, I'm just going to ignore it. But I didn't really physically understand why I'm ignoring the singularity. And so, like Professor was saying, you can run in ANSYS. There's a feature called non-linear modeling. And what non-linear is, like if you have your stress strain curve, you're in your plastic region, right? You're permanently deforming the part. But what parts do when they plastically deform is they're redistributing the stress. What that means is you're redistributing the stress in a way that's more favorable for the part, usually. And so that's why your stress may actually go down, but permanent deformation goes up. But that's all I wanted to cover. Are there any questions?
No questions? Okay, excellent. Thank you so much. Appreciate it.